Hey guys, this week what I wanted to do was go over some of the basics of networking. I know I talked about VLANs last week and realized there were probably some concepts that might be new to people. So let's go over the basics. Each computer has a networking component to it. It could be Wi-Fi, it could be a network cable, it could be a USB network dongle. Each one of those networking components has what's called a MAC address. It's a series of hexadecimal numbers, usually separated by a colon when they're shown out or a dash. And that identifies the device. Now, you see an IP address, right? Your computer might say 192.168.0.55, for example. But that IP address is what the network is going to find it with, but the device itself is identified by its MAC address. In order for you to have an IP address, there's a thing called DHCP, Dynamic Host Configuration Protocol, and that's going to go and look at that MAC address when it comes in and assign it an IP address. Now, if you'll notice that a lot of times your IP does not change, and the reason it doesn't change is because it remembers that computer, right? So your computer logged into the DHCP and that gave it an IP address and it gives it a lease, how long that IP address is going to stay. The reason for that is if that device goes away, you want to be able to reuse that IP address at some point in the future, right? Now, this is usually for a regular household handled by your router, right? You've got some kind of modem, modulate, demodulate, that connects to the outside world, be it to the old telephone lines, to the cable company, to your fiber. There is a device that communicates the bits back and forth. After the modem is the router. The router is what's going to handle certain functions. One is domain name service, possibly, but it is definitely going to handle DHCP, Dynamic Host Configuration Protocol. Now, the reason I say DNS possibly is your DNS can be handled by your internet service provider. The person you're paying to get your internet service from has domain name servers, or you can just point it to 8.8.8.8, which is Google, and have it be your name server. So putting the names aside for right now, dealing with just the raw internet connections, each computer has an IP address. You, to the outside world, your house has an IP address because that's what your internet service provider gives you. And again, that's associated with a MAC address inside your home, the one in your router or your cable modem. So once that's handled, right, and that device is identified by MAC address, an IP address is associated with it, and everything on the internet will communicate via IP addresses. Now, we're not going to get into the differences between IPv4 and IPv6. It's a completely different schema. IPv6, in theory, could give a unique IP address to every device and never repeat. IPv4 does not. So we're going to just deal with IPv4 because that's what most people are going to see. That 192.168.0.55 that I talked about earlier. That range goes from 0, 0, 0, 0 to 255, 255, 255, 255, right? So that's the limit of the number of devices that you can put in that address range. Certain address ranges are assigned on the internet to certain companies. The only people that are going to be using that particular IP address range is that company. But in your home, you don't have that same limitation because you're not talking to the internet yet. That's going to go through the gateway, another discussion, but everything in your home is going to talk to each other off of its own set of IP addresses, and you get that full range. If you're using the 192.168, you've got 00 to 255, 255. Right? So that gives you quite a few devices that you can hook up to that range. Now, there's reasons you might want to split that range up. You may want to put all your printers in a particular range, right? You may want to put your, if you have other networking equipment, you may want to put that in a particular range. So they're grouped together. But each one of those things can have a DHCP reservation. Now, what a reservation does is it says this MAC address will always get this IP address. Right? Let's say you've got a printer on your network and you have certain things on your computer that need to talk to it by IP address. You want that IP address to always stick. I've got a Dell network computer here that everything calls out its IP address and a port. And if that IP address changes, I have to go back through and make changes to the configuration so it can still print to that printer. So by putting something together that has a reservation for that IP address to that MAC address, make sure that your computer always sees that device on that IP address. The other way to handle it, if your stuff can take it, is to set up a domain name server inside your house. What that allows you to do is associate a name with an IP address. It does not fix the problem of your IP address changing, but it does allow you to call things by name as opposed to by IP address. So, for example, I could call something Dell Printer instead of calling it 192.168.0.32, for example. Makes it a little cleaner. There's always going to be certain things that you're going to have to call by IP address. If you've looked at your network settings, which you can get to through your operating system, you can see your like ipconfig will give you a list of all the information, ipconfig/all on a Windows box. You can do the same thing on a Linux box to get the information about your network connections. IP space address, for example, in Linux will give you the IP address of that box. Along with that could come other information of what your DNS is. Now, the DNS is always going to be an IP address. It's never going to be a name. Why? Because how does it know what the DNS server is if the name doesn't exist? So you're going to give it an IP address for that. That doesn't mean that the machine doesn't have a name. It just means that the IP address is associated with that. With your own DNS, you can set multiple things to point to a box. For example, if you had a SQL server, a mail server, and a web server all on one box, you could call them all by different names. They'll translate to the same IP address. You'll go to the same place, but you get to see it as a singular name like web.mybox.com. I wouldn't use the .com internally. I would use .local internally, but to each their own. But that way, when you call it, you're calling the web, right? You're calling a printer. It could be printer.mybox.local. It doesn't matter what it's called, except that it associates with that IP address. And that's when the DHCP becomes critical, having those reservations, because then your DNS will always point to that device because the IP address won't change, and the DNS allows you to call it by something other than IP address in places where you can. Not every place are you going to be able to do that. Also, some of the DNS allows you to do a more authoritarian or a more authoritative lookup so that it only accepts something from an authoritative site. So you're not getting somebody just popping up and deciding to call a certain IP address a certain name and somehow populating that out to the network. You're never going to have that issue. You're never going to have a corrupted DNS. This is only going to come from an authoritative source. Sorry, I'm having trouble with that today. But that source is the source of truth for that IP address range. And so you're getting the gold standard of what the DNS name should be. So again, everything comes back down to MAC address, right? So your MAC address, which you will see printed usually on something that came with your computer, will tell you a MAC address. If you look at your router, it's going to have a MAC address on it. That MAC address then gets associated to an IP address through Dynamic Host Configuration Protocol. It can be permanently associated to it by having a Dynamic Host Configuration Protocol reservation associating the MAC address to the IP address. That means that the DHCP server will ignore that IP address and that MAC address. It already knows what to use, so it'll always give it that IP address, but it also knows when it's handing out IP addresses that this one that is reserved cannot be handed out to somebody else, just like a reserved table at a restaurant, right? It's got the little reservation sign on it. Nobody's going to sit there except the person who has that reservation. Then you can associate a DNS internally to talk to that IP over a name. And if you're going to do a DNS internally, you're going to probably want it to have a link to the outside world, and you're going to want it to be able to get other DNS items. Now, what this does is speeds things up quite a bit, because every time you go to a web page, if it has to go do a lookup, right, it's going to go out and get that lookup. And that's why there's a thing called TTL, time to life, or time to live. And that is how long that is a good name until you have to go look up a new name. Go check it again. So by having that internally, you're just calling to an internal box. You don't have to go from your computer, through your router, through the modem, out to Google or whoever's doing your stuff, or your ISP, and then from them, get it back. That's why ISPs keep their own DNS, because that way, by having their DNS there, it's a quicker call for you to look things up, and it comes back quicker. Having your own inside means that you get to name everything that you have in your house, making it easier for you to keep track of what everything is. But it also means that if it's looking up Microsoft, or it's looking up Google, or it's looking up Amazon, any of those IP address associations will automatically get put into your cache locally. So when you make a call, assuming that it's still a valid IP, your call goes out. And what I mean by valid is if the time to life on it has expired, then it will go look it up. It'll have to go back out to the internet, out to that authoritative source for that domain name and IP address, and get the range from there so it can drop that back in your computer. So Amazon.com is associated with these IP addresses, or this IP address. And it stores it locally, again, so that you're just doing a local hub. Your computer probably to the same router, and back to your computer with an answer as to where it needs to go on the internet, what IP address it needs to have. And your browsers don't show you the IP address that it went to. It just shows you the result. If you'd like to see the IP address associated with something, there is another command called nslookup, and you can give it the place that you're going to go. So you could do an nslookup space Microsoft.com, and it'll give you the IP addresses for Microsoft.com, and it'll probably tell you where it got it from. If you want to get it in a different source, you can just do an nslookup with nothing else, put in server space and the IP address of the server you want to use for the DNS, for example, 8.8.8.8, which is Google, and then you can query Google to look up those that Microsoft.com and have it tell you what the IP address is, which is great for using for troubleshooting to make sure that yours matches, let's say, Google. But having all that locally can help you out. But what I primarily wanted to talk about here is just the absolute basics. That MAC address to IP address. The IP address is given by a DHCP. That DHCP also has a reservation set, so it can have this MAC address always gets this IP address. And then as an add-on, you can add a DNS to it so that it gets a particular name to something inside your network. Now, again, all this stuff is handled for you, usually in your router. Your router is where your device plugs into or your Wi-Fi comes from. That is plugged into a modem, either that's then connected outside to your cable, to your fiber, telephone line if you're still using it, satellite if you've got that. So that outside signal goes through this modulate, demodulate. That gets turned into the signal that your router gets for transferring data back and forth. And anything that hits the router that is internal will stay internal. And on the outside world, you're going to have one and only one IP address as to where you are as in the wide network of things. So I hope that gives you a little bit of background of how all that ties together. And if you didn't understand last week's VLAN discussion, this will help with that. Now, to tie this with that VLAN discussion, so the VLAN is its own self-contained DHCP. So when you're doing that, for that VLAN, there will be a configuration server for that VLAN. So, for example, let's say you're using 10.10.60.1 is your gateway. 60 is your VLAN. That's right. So everything that goes out of that IP address is going to be 10.10.60. something. So that gives you about 200 devices. Don't want to push the ends of the spectrum too much there. So let's give you over 200 devices that you have in that VLAN. It can have its own DNS, right? It can look things up because, again, DNS doesn't care about IP addresses. DNS cares about MAC addresses. So that's all there. And that allows you to separate your networks up. So if you wanted to put all your printers in its own network, you could say, okay, 10.10.20 is going to be the place where all my printers live. And the printers are all going to be in that setup, and you're going to have a few IP addresses get associated with that. Then you could do a 10.10.30 that's, let's say, your desktop computers and your laptop computer. And then you could say 10.10.10 is where all of your networking stuff is going to live. Your DHCP server is going to live. Your DNS server is going to live, all down in there. And you can separate your network up by function. They'll all have their own little set of IP addresses, and they won't move around so much because it doesn't have that many devices in there. For me, the ones that I've got are all set up in such a way that my IoT devices, my Internet of Things devices, my light controllers and things like that, have their own set of IP addresses. So I never have to worry about those being integrated into the list of other devices for my network, right? That's its own set of IP addresses. It's in the 192s, but it's got its own set of 192s, and it's separated from the rest of my network. If I'm looking for a list of devices that are specific to my internals, my printers and things like that, I can just look at the 192.168 zeros, for example, and that collection of devices is just my home network. If I want to look at the IoTs and I've got them in the 60, I could say 192.168.60, and everything there are all my IoT devices, and I can see them all grouped together. It makes it very easy to separate your network up into logical things. Now, as a typical user, are you going to need that? Absolutely not. But here's the advantage. With a VLAN, because it's its own little kingdom, you can set up a different DNS setup for that. So you could set up a DNS server for that setup that is general to the entire network, right? You could say, all right, I've got this server here. I'm going to go 10, 10, 10, 3. And that is going to be my DNS server for the entire network handled. Or you could do like I did. I work remotely. I have certain ports on my switches and a Wi-Fi that's specifically set up for work. That does not use my DNS at all. It bypasses my DNS. It goes straight out to the internet for all of the name lookups, so that it doesn't interfere with or be interfered with by a VPN that's running on that system. It's not going through a normal channel, if you will. It's kind of bypassing everything, going out directly to get the DNS externally. Again, if you're just running a small home network, it's not going to matter. But if you're doing things for work and other things, I strongly suggest you look at ways of setting up a VLAN, of setting up a way of splitting your stuff up, especially if you've got IoT devices, and keeping them and their traffic separated from the rest of the stuff in your house. It just makes life a little easier, and it's not looking to make calls to certain places. For example, if your switches are set up in such a way that it only handles traffic for one of your VLANs, that's all it's going to handle. It's not going to handle traffic for anything else. So if you've got a VLAN set up for IoT and you've got both cabled and Wi-Fi devices, your Wi-Fi device is probably going to be on a port that takes everything, because to cut that back would mean it can't handle it, unless you want to have different Wi-Fis in your home. Again, we're adding a lot of expense here for little benefit, because if it's all going to go off that one channel on your Wi-Fi and everything you've got is wireless, it's just going to use that one channel on each of the Wi-Fi devices you have in your house. So it's going to communicate on that channel and not even really have to call back that much. It needs to call out. It's going to go back through your switch. It needs to just talk to another device internally to their house that's in that same VLAN. It's just going to do that and keep the traffic away from the other devices in your home. But hopefully this little background, which has gone a little longer than I expected, but hopefully it gives you a little understanding of MAC addresses, IP addresses, what a DHCP reservation is, and what a DNS entry is. And that's what I got for you guys this week. I will talk to you all next week.